So what did I just do? Technically, what I just did was called the general power rule. It says the functions in example 2 and 3 are examples of one of the most common types of composite functions, y equals u of x raised to the n power. The rule for differentiating such functions is called the general power rule, and its special case of the chain rule. So it says if y equals u of x to the n, where u is differentiable function of x and n is a rational number, then the derivative of y with respect to x equals n times u of x to the n minus 1 times u du dx. So the derivative of u to the n is n u to the n minus 1 times u prime. So this is exactly what I just did on the previous page. Okay, and the idea is you don't need to use u substitution if you don't want. Okay, you can use u substitution. Let me show you what that looks like. So for instance, on this first problem, the inside is your u. So you would let u be the inside of the function, which is 3x minus 2x squared. If you found the derivative of that, the derivative of 3x is 3, and the derivative of minus 2x, or 2x squared, would be a minus 4x. And so really this is u to the third. So this says f prime of x would be equal to drop the power, which would be 3u to the power minus 1, which would be 2, times u prime. So that's a direct application of what they're calling what you see above highlighted in purple, the general power rule. And now you just back substitute. So this would be 3 times u. Here, let me show you what I'm substituting in. Here's u, and then here's u prime. So u is 3x minus 2x squared, quantity squared, times u prime, which was 3 minus 4x. And there it is. Okay? So your question might be, do we simplify anymore? I mean, it's in factored form. We're perfectly fine in factored form. The only thing I can see you doing is maybe distributing the 3 through to both of the terms, the 3 and the minus 4x, but there's absolutely no need. That is in factored form, and factored form is acceptable for these answers. Do I need to expand it out? Absolutely not. It's a total waste of time and could only potentially get it wrong for you. Okay? So that's more so the flavor of the general power rule. Again, I do even less than that. So when I'm taking the derivative with respect to x of 3x minus 2x squared quantity cubed, I don't even use u's anymore. I know all I have to do is bring the power down, keep the inside exactly the same, do the power minus 1, and then multiply times the derivative of the inside. So here's what my work would look like. And again, if I do it, I would accept it on your test. So if you show this work, we'd be fine with that as well. So drop the power, keep the inside exactly the same, to the power minus 1, but then we need to remember to multiply times the derivative of the inside, which is 3x minus 2x squared. We need the derivative of that. Well, what's the derivative of 3x minus 2x squared? That is, we already decided to be 3 minus 4x, and that would give us our final answer of 3 times 3x minus 2x squared, quantity squared, times 3 minus 4x. And that would be our final answer as well. So you could go ahead and do it the way on the right, where you don't even use u substitutions. You could use light u substitutions like I did on the left, or you could do the very formal version of the chain rule, which we did on the first problem of the section. Totally up to you. Okay, let's look at example 5 then. Example 5 here says, find all points of the graph of f of x equals the cube root of x squared minus 1 quantity squared for which f prime of x equals 0, and those for which f prime of x does not exist. Okay, so we got a lot of work to do here, but the first thing I want to do is I want to rewrite f of x as something raised to a power. So this is really x squared minus 1 raised to, well, the cube root of x of that thing squared. The power stays in the numerator, the root becomes the denominator, so that would be x squared minus 1 quantity to the 2/3. So if I wanted to find the derivative of this, I could use that general power rule. Again, what do you do for the general power rule? I'm not going to use the u substitutions anymore. I'm just going to show you what I do. Drop the power. The inside stays exactly the same to the power minus 1. So we got to be a little careful with that, right? 2/3 minus 1 would be negative 1/3. But remember, you always have to multiply times the derivative of the inside. That's the most missed part of this problem, is forgetting to multiply times the derivative of the inside. The derivative of x squared minus 1 is 2x. Do a little bit of simplification here. 2/3 times 2x would be what? 4/3 x times x squared minus 1 to the 1/3, or negative 1/3. So if we did even a little more simplification, that would be a 4x in the numerator, a 3 in the denominator, and then a negative 1/3 power. In the denominator is a power positive 1/3, which is a cube root of x squared minus 1. So if they ask for the derivative, that would be the simplified form of the derivative. Okay, notice it is a fraction here. So the question asks us, when is the derivative equal to 0 and when is the derivative undefined? Okay, not an issue. We can work with that. A derivative is equal, or a fraction, I should say, is equal to 0 when a numerator is equal to 0. So f prime of x equals 0 when the numerator equals 0. So the numerator is 4x equals 0. Divide both sides by 4, and we're going to get x equals 0. So that's when the derivative is equal to 0, would be at x equals 0, when x equals 0. And it says find all the points, so technically what we should be doing is plugging this back into the original function to find the y value. We'll do that in just a second, though, okay? It's a little hard to, well, that's fine. Okay, so when is f prime of x undefined? A fraction is undefined when the denominator, which is 3 times the cube root of x squared minus 1 equals 0. So what I do, I divide both sides by 3. When I do that, I'd have the cube root of x squared minus 1 equals, well, 0 divided by 3 is 0. But what I do now, to get rid of a cube root, I cube both sides. So I'd have x squared minus 1 equals 0 cubed is 0. I know this left-hand side factors into x plus 1 and x minus 1 because it's a difference of squares. That helps me not forget one of the answers, because several of you will forget the plus and minus if you do the square root. So I'm getting the answers negative 1 and 1. Negative 1 and 1. So where is it defined? It's defined at x equals 0. Where is it equal to 0? The derivative equal to 0 when x equals 0. It's undefined when x equals negative 1 and 1. Those would be our final answers for those problems. Of course, it technically says points, so technically what we should do is plug those numbers back into the original function and see what we get. So if we plugged in 0 in there, you would have negative 1 squared, which is 1. The cube root of 1 is 1, so that should be a 0, 1 as a point. And then if we plugged negative 1 in, negative 1 squared is 1, 1 minus 1 is 0, and then the 0 squared 0, cube root of that is 0. So that should be a negative 1, 0. And plug in a 1. 1 squared minus 1 is 0. Squared is 0. Cube root of that is 0. So that would also be a 1, 0. So if they said points, technically you should do ordered pairs because it says points. Let me highlight that. It says points, you should do ordered pairs. But I'm looking in the e-text, and all it gives is the x values of those points. So I guess I would have accepted either of those on the test then.